Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with the problems on students recommendation XEB 2016, the question 9. This is the last of the 1 mark question. It is from fluid dynamics. I put it on fluid dynamics because it's a trivial question in fact. Okay, let us see how it works out. Okay, so consider a fully developed steady incompressible 2D viscous channel flow with uniform suction and blowing velocity V0 as shown in the figure below. The centerline velocity of this channel is 10 meters per second along the x direction. The value of V0 at both the walls is 1 meters per second and the value of y component of velocity inside the flow field is dash. Now, first of all we have to understand that they have said there is a fully developed incompressible flow. Now, this one is only in the x direction. So, if it is in the sense, if it is like this, there is a parabolic flow which is established. Now this parabolic flow which is there, this velocity profile will be of u component of velocity, whereas the v component of velocity will come in this direction, which is equal to say 1 meters per second. Okay, so they are saying it is already established. Okay, so just like if I put the Navier-Stokes equation, you put u dou u by dou x plus v dou v by dou y is equal to minus 1 by rho dou p by dou x plus nu into say dou square u by dou x square plus dou square u by dou y square and so on, right? Similar way in the v direction, right? Dou v by dou x and so on like this. Now here if we observe, this can be there together. Both of these things can be there together. Okay. So if the v component of velocity is 1 meters per second and u component is 10 meters per second, okay, the v component of velocity, the value of component of velocity inside the flow field will remain the same. It doesn't change. So it will be 1 meters per second itself, v component of velocity. Correct. If it is on the walls 1 meters per second, it will be the same in the other places also, because there is no way that v component has to be reduced. But yes, when the u component, which is 10 meters per second, is coming with 1 meters per second the v velocity, then yes, the direction will obviously change. The direction will come in this fashion, which is 10 square plus 1 square square root of that, so much of the magnitude, and the velocity, corresponding velocity we can find using tan, which is tan inverse of 1 by 10. That would be the angle here. Okay, but what they are asking, the y component of the velocity, it is same as 1 meters per second. So that's why I said it is trivial. Okay, only thing is that you have to understand how this works out. Okay, when we can do it as a separate components like this, we can as well say, because they have said that it is established, 1 meters per second is established there. So there is no further thing to be thought about. It is 1 meters per second itself. Thank you very much, students.